Right, so again, sorry for that one. So I wasn't able to check the time. So anyway, so from there we can now get the value of your voltage across R3. Okay? So just get the current, which is 0.286, and then the individual resistance, which is 40. Okay? So 0.286 times 40 will give you 11.44 volts. All right, so let us wait 1 more minute for the others. So while waiting for the others, this is now your chance to ask a question. So what part gave you a hard time in understanding how to solve a circuit using KVL and KCL? Or were you guys able to follow?
Hmm. Hmm.
So how many percent that you guys were able to, clearly understand this example number one? 50%? 70? Go guys. Wow, that's great. So coming from Mr. Aaron Sagipo, so he said that it's around 70% for him. Anyway, so you can always go back to this part, slide 17, 18, 19, to recheck your own solution. Okay, so of course I have here the briefer solution. I made it as short as possible. Okay, so unlike here, it has a longer way of derivation. But uh, even though you have a longer derivation, you should have the same answer anyway, which is 0.428 or 0.429. How about the others? How many percent that you guys were able to understand the example number one? You guys, are you guys there already? Seems sure. 70%. All right. Okay, then, so let me just show this one. So the one that we're trying to solve here is the current flowing in the 40 ohm resistor R3. So the answer for the number one is 0.286 amps. Okay, so this is just a bonus. Okay, so the voltage across R3 is 11.44 volts. Okay, so again, the negative sign for I sub 1, so this is 1, means that the direction of current flow initially chosen was wrong. Okay, but nevertheless, is still valid. Okay, in fact, the 20-volt battery is charging the 10-volt battery. Right? So here are some application of Kirchhoff's circuit laws. Okay. So these two laws enable the currents and voltages in a circuit to be found. For example, the circuit is said to be analyzed. And basic procedure for using Kirchhoff's circuit laws is as follows. So number one, assume all voltages and resistances are given. Okay. If not, then label them. Okay, as your V1, V2, V3, R1, R2, R3, etc., etc. And then you must assign a current to each branch or mesh. So it could be clockwise or clockwise. So any of those two. Okay. And label each branch with a branch current. Okay. Like for example, this one, we have this current I sub 1, current I sub 2, and then current I sub 3. So those three currents are just actually assumptions wherein we have this current flowing from here to there. Okay, from here to there. Okay, so it's flowing clockwise, and here it's flowing counterclockwise. So those are just assumptions. And then, so once you're done in doing those three steps, then you can now proceed in KCL. And then after having the KCL, you may now proceed in KVL, okay, just like what we did a while ago. And then use linear simultaneous equations as required to find the unknown currents. Okay. So in our case, we find it using one unknown, okay, just by forming a formula out of the other equations, and then having one unknown and then substitute it, and then getting the value of that unknown. Right? So application of Kirchhoff's circuits laws, as well as using TCL law to Kirchhoff's circuit law to calculate the various voltages and currents circulating around a linear circuit. So we can also use loop analysis to calculate the currents in each independent loop, which helps to reduce the amount of mathematical required by using just Kirchhoff's laws. Okay, so what is this loop analysis? So I included a video on the module overview wherein you can see how does a loop analysis work versus KCL and KVL analysis. So yeah, you can visit that one. Though they are quite the same with the concept of the Kirchhoff's law, right? Anyway, so we have this another example. Okay, so we have the parallel part here for the node E and node B. And then we have here another parallel connection, which is for the node F, E, and then B. Okay. And then we have a voltage source of 132 volts. Then it is assumed that the current is flowing from this point and then going back to this original position. Okay. So I sub T, okay, or total current is up this side. And then your IT will be divided to 2, which will flow on the I sub 2 and I sub 1. And then it will go back as your IT once those two currents combine with each other. And then will be divided into 3 again. Okay, I3, I4, and then I5. And then we'll go back here as your total current. All right. So what is the question right here? So solution and explanations. In this example, there are 4 distinct junctions for current to either separate or merge together at nodes A, C, E, and node F. So the supply current I sub T separates at node A, flowing through resistor R1 and R2. Okay, and then recombining again at node C before separating again through R3, R4, and then R5. And then finally recombining again once at node F, okay, or at this node. But before we can calculate the individual currents flowing through each resistor branch, we must first calculate the currents, the circuit's total current, or I sub T. Ohm's law tells us that I is equal to V divided by R. And as we know, the value of V is 132 volts. So we need to calculate the circuit resistances as follows. So again, after this point, then you must now answer this one on your own. And then try to, only use this one as your basis, whether your answer is really correct or no. Okay. So from here, our goal is to solve for the individual currents flowing to the R1, R2, R3, R4, and then R5. Okay. So yeah. Anyway, so let me just explain this one since we already have the solution. So from here, our total current will be separated into two, I1 and I2 for R1 and R2. So from there, you can actually solve the total resistance of those two, call this one, those two resistance. Okay, so combine those two using the formula 1 over R1 plus 1 over R2. Okay, and then you will get, I guess, 1 ohm. Okay, and then from there, you can now get the total current that is flowing on this two nodes. And then what happened next? And then he also combined the three resistors in here, R3, R4, and then R5, and then you've got 10 ohms. And then what else? And then we've got the total resistance, which is the combination or the summation of those two summation parallels, so REC and then RCF. So 10 plus 10 plus 1 is equal to 11 ohms, which is now this one. And then we now have the total resistance from this circuit. So you can now solve for the total current. So I sub t is equal to V divided by RT is equal to 132 divided by 11, okay, which is equal to 12 amps. We still have wait, 132 volts, RC 1 ohms, RCF is 10 ohms, and I sub t is 12 ampere. There you go. All right. So from there, we've solved for the total current for now. Okay. And then once you have that one, then you can have this new circuit out of this circuit. So this is the combined RAC. And then this is the combined RCF from those three resistors. And then these are just the summary of your answer for now. So total of 132 volts, and then 1 ohm resistor, and then 10 ohm resistor. Okay, and then the total current is 12 ampere. And then from here, you can now solve for the individual currents using their individual resistance. Okay, so let's say I sub 1. So I sub 1 is equal to VAC, okay, which is of course 12 volts. So how did we get this 12 volts? From the total current multiplied by the resistance on that part, which is 1 ohm. So the IT is 12 ohms. And then at this point, okay, the RAC, we have 1 ohms. So 12 ohms times 1 ohm, it will give you 12 volts. So from there, we have a voltage that is flowing on each of those two, R1 and R2, which is 12 volts. Okay. And then for the VCF, we have the 12 times 10, so 12 for the total current, and then 10 for the resistance on the CF. So 12 times 10 is 120. So from here, we have 120 volts that is flowing for the R3, R4, and then R5. Okay. So from there, you can now get the individual current since you now have the individual voltage and then the individual resistance. So we have VAC divided by R1 or 12 divided by 2.4. So again, this R1 is coming from this right here, 2.4. And then the other one is 1.7, 60 ohms, 20 ohms, and then 30 ohms. So just use their own individual voltages and then own individual currents. So from there, you will be able to solve the I1, I2, I3, I4, and then I5, which is 5, 7, 2, 6, and then 4. Right? So you really need to do this one with paper. Okay. So, are we clear with this part? Circuit, resistance, RAC, and then RCF? No?
Yes, sir.
Okay. So once you're done with this one, then you can now, form a new circuit. Though this one is not needed. Okay. You can jump through here right away. Okay. So again, for you to be able to get the individual currents, especially if it's a parallel circuit, you have to get the individual voltages across it. Okay. So the voltage across AB and then the voltage across CF. Okay. So that's how we've got those individual currents. So, any questions so far? So, yeah, I'm sorry since we cannot have a better presentation since I don't have a blackboard, okay, or a whiteboard, and we could have a better solution. Anyway, so just in case you're there is a part or you've encountered the problem wherein you cannot really understand it, so feel free to message me anytime so we can have a decent discussion, a one-on-one discussion. But yeah, if possible, try your best first. Okay, visit some website, visit some YouTube tutorials on how to solve individual currents, how to solve a voltage drop using Kirchhoff's law, and loops analysis. So those two for now, loop analysis and then Kirchhoff's law. Okay, so yeah, oops. So we have a continuation here, solution and explanation combination. So we can confirm that Kirchhoff's current law holds true around the circuit by using node C, okay, as our reference points to calculate the currents entering and leaving the junction S. So from here, we have at node C, we have this AB going in, or I sub 1 plus I sub 2, and then minus I sub 3 minus I sub 4 minus I sub 5, which is now this one. Okay, so the negatives are just transposed on the other side of the equation to remove the negative sign. Okay, and then if you want to check, the values that you have got from the I1, I2, I3, I4, I5, so you can use this law, the KCL. Okay, so we have this total current, which is 12, and then I sub 1 plus I sub 2, which is 5 plus 7 is 12, and then we have I3, I4, and I5, which is also equal to 12. Okay, so in that case, KCL comes in play. Okay, so yes, we have applied the basic of the KVL, especially the flow of current, as I'm assuming that this is the flow of current, and yeah, we can also use Ohm's law at the same time. Okay, so you can combine Kirchhoff's law and then Ohm's law to have a better or a quicker understanding or in solving a circuit. Okay, so you're not limited in using KCL, KCL only, KVL, KVL only. So you can always apply what you have learned in Ohm's law. Like for example, if it's only asking to solve for the total current, then just by looking at the circuit, it's easier to apply the Ohm's law analysis instead of jumping in, applying the KCL analysis. Okay, so yeah, there you go. And then you can also check this one using Kirchhoff's law or vice versa. All right. And we have here the third example. So I hope that this one or this part is clear to you guys, because you will, just getting bothered that you wasn't able to understand example number 2. So the risky part on that one is the concentration that you have a while ago will like divide it into two, because you're still thinking, okay, how did we get the example number 2? Okay, so if possible, I would like you guys to, uh, I would like to know whether you guys really understand the example number 2 or no. So is there anyone here who still wasn't able to follow or understand the example number 2 before we jump into example number 3? So none. So all of you were able to understand example number 2? Also none. Okay. So are you guys still there?
Yes, sir.
Hindi ko alam kung nandiyan pa kayo. Anyway, so sobrang hirap talaga. Anyway, kapag may problema kayo, message na lang ako. Okay. So for now, just try your best in, understand this one, self-study with your own understanding. Okay. All right. So let's now jump to example number 3. So find the currents flowing around the following circuit using Kirchhoff's current law only. So take note, Kirchhoff's current law only. So there are some questions like this wherein it will force you to apply Kirchhoff's law. Okay. So yeah, we can get the answer right away just by applying the Ohm's law. Okay, just solve the parallel of this one and then combine those two, and then you will get the total resistance. And then from there you can now have the total current. But since we are asked to apply only Kirchhoff's current law, then we have to do as what it is being told to us. So here's the solution explanation. So again, we have this node right here, A, B, C, and then A, B, B. Okay, so we can have that one as your loop number 1 and then loop number 2. So if you're going to write this one on a paper, so we have the ABB, so inside right here, so A, B, and then B. And then we also have the loop, which is the A, B, C. Okay, so A, B, and then going to C, and then go back to its original position. Okay, so were you guys able to get that one? And how did we get these two expressions using those two loops, A, B, C, and then A, B, B?
Yes po.
Yes, sir.
So again, from there, you just apply what you have learned a while ago. So just be consistent with your signage. So we have positive, negative. So positive, negative right here. Positive, negative, positive, negative. So from here at say A, B, D at loop 1, so we have positive 12 volts minus I1 times R1 minus I2 times R2 is equal to 0. So this is your I3 times R3 is equal to 0. So this is your A, B, B. Okay, nasa loob. And then the outer side is ABC. So positive 12 volts minus I1 times R1 minus I2 times R2 is equal to 0. So this is your loop ABC. right? So that's how we've got those two expressions. And then here's the continuation. From here, we have this, we have this. So we've now used the KCL, but I guess I wasn't able to show that one right here. So yeah, I wasn't able to show the KCL. Anyway, for the KCL part, as you guys can see, we have this node B, wherein we have I1 flowing or entering or flowing in, and then we have I2 and I3 leaving the node B. So minus I sub 2 minus I sub 3 is equal to 0. And then from there, you can have this formula. I sub 2 plus I sub 3. And then from here, we can actually substitute this one, either of those two. So pwedeng dito sa ABB or pwedeng dito sa ABC. Okay. Anyway, so in here, we have already substituted the I sub 2 and I sub 3. And then I sub 2 and I sub 3 for both of those expressions. And then just simplify it more. Okay, and then you will get this kind of expression. So 12 is equal to 10 I sub 2 plus 4 I sub 3. And then 12 is equal to 4 I sub 2 plus 16 I sub 3. And then from here again, so we can form another formula wherein solving for I sub 2. Okay. So where is that part? I sub 2, 12. So in here, we did another approach wherein Hiv eliminated one of the variable using what do you call this one? Tawag tayo dito eh. So let me just get this one. Oops. So in here we have the equation number 1 and then equation number 2. So these are the original simplified version. So what he did in here is he tried to remove the other variable by multiplying each of the expression by a certain value. Wherein in here he multiplied 2 times 4 to get the 16 I sub 3. Okay, of course you have to do the one on the entire equation. So you will get 48 is equal to 10, 40 I sub 2 plus 16 I sub 3. And then we have here times 1 only, like he didn't change anything. So it's okay since you didn't really change anything. So 12 is equal to 4 I sub 2 plus 16 I sub 3. And then from here, we can actually do a subtraction right here, wherein 16 I sub 3 minus 16 I sub 3 is equal to 0. Okay, plus 0. And then 40 I sub 2 minus 4 I sub 2 is equal to 36 I sub 2 is equal to 48 minus 12 is equal to 36. So medyo magulo, ayusin ko lang. So 36 is equal to 36 I sub 2. So there you go. And then from here, you can now solve for the I sub 2. I sub 2 is equal to 36 divided by 36 is equal to 1. Okay, 1 amps. So I forgot the name of this process, but we have the 3 unknowns and then 3 the same variables wherein you can also apply this subtraction right here. Okay, it's just like solving subtraction math, okay, on a certain expression. Oops. Oh, simultaneous equations. Yeah. So that one. So from there, you can also do this one, okay, especially if you can get the same, or if you can eliminate, okay, either of one variable, say I2 or I sub 3, so either of those two. And then you can subtract and then solve for the remaining unknown, which is, let's say, right here is I sub 2. And then from here, you can now substitute this I sub 2 on either of those equations. Okay? And then you will get the I sub 1 right away. So from here, we have I sub 2 as 1 amps. So just like what we have solved in here, 1 amps. And then so substitute the 1 amp on the, okay. So he didn't substitute it, but still, he still used the simultaneous equation, wherein he multiplied 4 on the equation number 1 and multiplied 10 on the equation number 2 to have the same result on the I sub 2. So in that case, we will now be able to solve for the I sub 3. Okay, so are we clear up to this point? And then from there, you can now again get the value of your I sub 3 since I sub 2 will now be cancelled. So are we clear so far, guys? And how did we get the I sub 2 and I sub 3? Hello, guys.
Yes po.
So for the I sub 2, simultaneous equation. And then for the I sub 3, still simultaneous equation. So were you guys able to follow? At least 50%. I'm not really expecting to have 100% understanding since 30 straight. Okay. So anyway, again, yeah, so mahirap talaga lahat na pag mahaba yung solution. But anyway, it's like literally 70% self-study for you to be able to understand the Kirchhoff's law, especially this is your first time, learning about Kirchhoff's law. So yeah, do a lot of self-study, solve a lot of examples, and then compare your answers, compare your process, and then yeah. So you can also message me to show your solution if you want me to check it, whether you really, if you're really doing the correct process or no. Okay. Anyway, so from there we can now get the value of your. So we have, where's that one? Oops, I've lost it. Anyway, so we have the I sub 1 is equal to I sub 2 plus I sub 3. So your I sub 1 is 1.0 plus 0.5 ohms. So I sub 1 is 1.5 amps, right? And yeah, there you go. So you now have the individual currents that is flowing on your circuit. Okay, I sub 1 is 1.5, I sub 3 is 0.5, and then I sub 2 is 1 amps. Right? And what else do we have in here? So we don't have enough time anymore. Only have 5 minutes. Anyway, so let's just discuss whatever we can discuss. So for the Kirchhoff's voltage law, so what do we have here? All right, so this is just the explanation, just like what we have a while ago, wherein the voltage drop across to this circuit is equal to the 0 or equal to the voltage source. Okay, or just simply the summation of voltage is equal to 0. Okay, and here's the equation that you will get from this loop. So Vs plus minus I1 times R1 plus minus I2 times R2. Okay, wherein Vs is equal to I times R1 plus I times R2. Okay, so we've only put here I since this one is in a series format, wherein all of the currents that is flowing on this circuit is the same. So that's why I only. And then from here, your R1 plus R2 is equal to R total. So you can simplify it to R total only. So Vs is equals to I total times R total. Okay, wherein of course your R total is equal to R sub 1 plus R sub 2. And what else? I1 is equal to R1. Where did this one came from? Yes, Vs divided by RT. I see. So this one just came from this R total. So if you want to solve for the I, okay, so we can have this equation Vs divided by RT, wherein RT is R1 plus R2. The same with this one. So if you want to get the voltage across R1, so it should be I times R1, okay, wherein I is equal to V divided by R1, no, R total, okay. So that's why we have this R1 plus R2 right here. And then the same with VR2, just a different numerator, which is the R2. And then 3 resistors. All right, so I think this one is easy, okay, since this one is in a series connection. So yeah, you can answer this one. And here's the solution anyway. The solution for letter A for the total resistance, solution for letter B, and solution for letter C, current to each resistor, and then the voltage drop across each resistor. So I would like you guys to answer this one on your own, okay, since we do not have enough time anymore. And then here's the letter E, which is the Kirchhoff's voltage law, or verification on the Kirchhoff's voltage law. So yeah, I guess this one is just a checking. Okay, so it's like Ohm's law for A to D, and the letter E is just a verification using Kirchhoff's voltage law. So they should have the same answer, since yeah, this is just another way of solving things, but you should come up with the same answer. Okay, Kirchhoff's and then Ohm's law. And then we have here Kirchhoff's circuit loop, which is also in a series connection. 12. I guess this is the I see. So this is the circuit. This is the circuit of your example number 4. Okay. So we have here the 12-volt battery, 10 ohms, 20 ohms, and then 30 ohms. So 10 ohm, 20 ohm, 30 ohms, and then the voltage drop. Okay, so 2 volts, 4 volts, and then 6 volts. And then the current that is flowing on each components. Of course, 0.2 ampere on all of the components, since this one is in a series connection. All right, so yeah, so we're done. So the theory behind Kirchhoff's second law is also known as the law of conservation of voltage, and this is particularly useful for us when dealing with series circuit, as series circuit also act as a voltage dividers, and voltage divider circuit is an important application of many series circuits. So again, this is the reference where most of those examples came from. So please check this one for more information. And then yeah, that's it. So I will announce soon. I will announce soon when I will publish the quiz. So maybe tomorrow or maybe next week. Okay. Or maybe right now. Okay. So yeah, that's it for the module 3. So again, 70% self-study and then 30% more on my presentation. So I would like you guys to do a lot of self-study and then have a lot of exercise, okay, for you to master the Kirchhoff's law. Okay,